In this video, we're going to learn how to fine-tune your large language model using something called QLoRa. QLoRa is a completely new technology that helps you fine-tune large language models, even with less computation power. Before we jump into QLoRa and the code actual, I would like to show you a quick demonstration of what LoRa is. So if you see the blue color as pre-trained weights of a large language models, if you're going through the traditional fine-tuning method, what you would end up doing is you would end up fine-tuning the entire set of weights, like all the part of the dense layers of the neural network. But what QLoRa does is LoRa creates a new set of weight matrices, or it's also called as update matrices, that you see on the right-hand side, the orange colored one, while freezing the blue color pre-trained weights. So the output activations of the original pre-trained weights are frozen and then are augmented by the new updated adapter, low rank adapter, that is also called as update matrices or weight matrices. And this is how you end up getting a smaller file after fine tuning while also not compromising performance and accuracy while doing all these things in low computation. Now, LoRa has taken a completely new turn with QLoRa. Thanks to QLoRa, now you can train a really large, let's say 65 billion parameter model on just a single GPU, a 48 gigabytes memory GPU, while preserving full 16-bit fine-tuning task performance. I'm not going to get into the details of QLoRa, but one interesting fact is that the authors who presented QLoRa actually created a new model called Guanaco outperforms all the previously released open source models on the Vicuna benchmark. This is before the arrival of Falcon. Let's leave Falcon out of it. And it said it reached 99 of the performance level of ChatGPT while only requiring 24 hours of fine-tuning on a single GPU. So bottom line, QLoRa is really an exciting space. And thanks to Bits and Bytes, the library called Bits and Bytes, we can fine-tune or load inference any model based on QLoRa. And that is exactly what we're going to see in this video, how to fine-tune a large language model using QLoRa. So we're going to use two main libraries called transformers and bits and bytes for doing the quantized LoRa, which is the LoRa. But we are going to use it with the quantization technique, and we need to install all the libraries, bits and bytes, transformers, PEFT, accelerate, and datas. So whatever model gets supported by accelerate, you should be able to do this entire thing based on for those models. So I'm going to show this demo with GPT-NewX. This is a Google Colab notebook that Hugging Face team has released, Hugging Face and Bits and Bytes team has released as part of the blog post. So this blog post has a lot of details, and you can read this blog post and also see this Google Colab notebook that can help you. First, simply, you're going to load the existing model, import torch from transformers. You want auto tokenizer, auto model for causal M and bits and bytes config. Now inside bits and bytes config, you're going to specify and then say you want to load it in 4-bit and you want to load it with all this information that makes it load a 20 billion parameter model, which is 40 GB model and half a precision. And that's what you're going to see. And now when you see this new type NF4, you can go to the blog post and read more about what is that NF4 type normalized float for value. And you can see the details around how does the N4 configuration work and what kind of quantization it is. Basically, you're trying to quantize the model, reduce the size of the model, and at a lower precision, you were trying to load the model in a lower memory machine. Like in this case, I've got a Google Colab machine. And if you see my Google Colab, it's a free Google call. I've got total 12 gigabytes of RAM and 80 GB disk space and 15 GB GPU RAM. So entire thing like this, fine-tuning and inference, all these things are going to happen in the 12 GB RAM, 15 GB GPU RAM, 15 GB GPU RAM, and 80 GB disk storage. And the model in itself is 40 GB and half precision. Next, we are going to download the tokenizer and download the model while downloading the model. We're going to download the model with the quantization configuration that we just specified before, which is the bits and bytes configuration. At this point, we have successfully downloaded the model. It takes a bit of time. And as you can see, it's a big model. It's a model from QLoRa AI, which was ideally supposed to compete with the GPT-3 world like long before. The introduction of Llama and other models. Once you have successfully loaded all these models, now you're going to do some pre-processing you need to do to train the model. So you're going to prepare the data or prepare the data or prepare the model, the existing model for training. So you're going to, from InputPath to import, prepare underscore model for key bit training. So that's something that you need to import. And you're also going to enable gradient checkpointing for the model and load the model with pre-prepare model for key bit training. And then you define print trainable parameters, like the model parameters details function. Now is the main part where you're going to specify something called LoRa configuration. So your LoRa configuration now is something that you're going to specify the LoRa configuration. So your LoRa configuration is where you're going to make the decision about what is that size of the new update matrices that you want to fine tune. So if you remember the initial animation that I showed you, this particular part that rank factor actually defines the rank factor defines what should be the size of the matrices. And that's going to have an impact on the computation that you need, on the memory that you need, and also the size of the output files. And now at this point, you're going to just give R is equal to 8. So that's the dimension of the update matrices LoRa alpha. And the target modules is something that differs for different kinds of models that you're using. So I'm using GPT Neo X for that, the target module, the part in which you want to, the part of the dense layer in which you want to make changes or fine tuning. That's this one. But it could be different for a different model. Maybe if you're doing a stable diffusion with LoRa, then this would be completely different. So you need to check what is that part and what is that model that you're using. So if you're going to use this code with GPT Neo, if you're going to use this code with GPT Neo OS, this will work without any issue. And also, if you want to update anything in BIOS and what kind of task it is, this is a simple causal task. And you can check the LoRa documentation where all these tasks, PIF documentation where the LoRa config, all these tasks, PIF documentation where the LoRa config, all these tasks are specifically given to you. Once you create the configuration, then you're going to use the model that we have already loaded, which is the GPT Neo X, which we have loaded as a quantized model with the configuration, the LoRa configuration that we just specified. And you're going to print the trainable parameters, like how many parameters are going to train. And as you can see, we're going to train 80 of the parameters. So if you see the trainable parameters, so like all the parameters in the model, you can see this is all the parameters in the model, the trainable parameters in the model. So how much are we training? We're actually training only the 8 of the total parameters in a large language model that we have got. So if it's like, let's say 60 billion parameter model, then if it is like 8, what is the 8? What is the 8? So that's what we're going to train only. And now we are getting into the training part. So to train, we're going to use simple English code data set. It's a very simple data set. It's a very simple data set. It has got only the training aspect, no validation or tests, and it just helps you create codes. You're going to load the data set. The data is available. Data of train will give us that. The next thing is why. So now what do we have? We have the base model ready. We have the base model ready. We have the LoRa configuration ready, and we have the training data set, the fine-tuning data set, ready. Now we're going to use that to use transformers trainer class to train the model. So what we're going to do is import transformers, whatever the padding token or end of sentence token that you need to use, depending upon the model, the tokenizer, you can add it and then transformers.trainer. You're going to give the model, which is the base model in our case, GPT, Neox in the training data set, which is the data of train. Like if you're going to do this, like supervised fine-tuning set or instruct fine-tuning, that instruct fine-tuning data set goes in here actually. And basic training arguments. So the training arguments, whatever you want to give the learning rate and all these things that you can give here. One another important thing is where do you want this model to store the output to be? And this is another place quite important because your LoRa that you're training will get saved here so you don't have to look anywhere else. So specify the output directory where you want to save the adapter or the LoRa weights. The model, let's call it fine-tune model. Run this entire thing, and once the trainer starts, just goes on. And once the trainer starts, just goes on. And as you can see, the training loss goes down. And finally, you can see how much time it totally took. It took about, let's say in this case, 169 seconds for the training runtime. And you can see for every iteration how much time it took total loss, and all the information you can see. Started with 2.38, it ended up with 2.46. You can see at some point it started overfitting, and somewhere the best is, let's say, 8, and you can see all the details there. And then now what you have completed is you have completed the fine-tuning of a huge model, a 20 billion parameter model GPT NEOX, which is 40 GPT NEOX, which is 40 EB in size, in half a precision inside Google Colab, which has much, much lesser memory. Now, the next thing is, if you want to use the model, there are multiple ways to do it. One, you can push it to Hugging Face Model Hub, which I'm not showing you here. But if you want to save the model locally, one, you could already go here and then look for it. But in case if it's harder for you, you can go here and start running this code that is to save the model, save the pre-trained. And when you save this model will have, it's not like your regular PyTorch model. So if you go here, you will have like files like this. What are those files? You will have adapter underscore config.json, adapter underscore model.bin. These are the files that you would see when you save the model. And those things now you need to load using the same LoRa configuration that you've got. So you're going to, from pre-trained, loaded using the same folder from where it is. And you already have the base model, and use the base model and the LoRa configuration, and use get underscore piff underscore model to use piff to load the model. And once you have that, then you can basically use the model just similar, like how you use any transformer models. If a prompt text, set the device, and then you have to say, okay, use the tokenizer to tokenize it, but send it to this device, in this case CUDA, and then use the outputs, the model.generate, which is the model.generate, which is the model that is with the base model and also with the LoRa component. And in this case, it's quantized LoRa. So it's a QLoRa component. So ultimately, you're going to combine these two, and that's exactly what we are doing in this step. We have used the base model, but also the LoRa configuration, which is the fine-tuned component that we have done and now finally printed. And unfortunately, in my testing, I didn't get any code, but the whole concept of training and fine-tuning actually works very fine. So now you can push it to Hugging Face Model Hub, just like the creator of Bits and Bytes, Tim Detmers, have done. So you can go to Tim Detmers' profile, and you will actually see a lot of QLoRa weights being shared here. QLoRa Alpaca, 33 billion. QLoRa Long Form, 65 billion. QLoRa Flan, 33 billion. And also the main model that I said, the Guanaco model, is also being shared. So you can try out all these models, but if you still want to fine tune this model on your own data set, then this Google Colab notebook should help you do that. I'll link the Google Colab notebook in the YouTube description. But for you to understand the Google Colab notebook better in detail, you can go through this blog post that will give you all the details about what is the quantization that we are doing, what is the LoRa that we are doing, and how Bits and Bytes are helping us integrate this with transformers. But even if you do not read the blog post, only by watching this video, you should be able to successfully fine-tune a really large language model, which otherwise wouldn't have fit in your, let's say, Meteor Tux 3080 or 2090 or even Google Colab memory. But now you can do that with QLoRa, thanks to this amazing innovation that they are calling this as democratization of large language model fine-tuning inference. I hope this video was helpful to you. Let me know in the comments section. What do you feel about this? See you in another video. Happy prompting.